So I'll just briefly mention two agile methodologies. So this one is called Scrum. So in many cases, what we want to do is not to spend a lot of time understanding or planning for this particular project and then we execute it. But we just have to define what we want and then plan for a very short period of time, let's say 2 to 8 weeks. So that period is called a sprint. And then we just want to know what we want to accomplish in that sprint. And then we take a sprint and then we come back say, okay, so does that work or does that accomplish whatever we want? And then if it doesn't, then we plan for the next one, then we plan for the next one until we get the working system. So we want to focus on our development into these sessions, these sprint sessions, so that we will be able to maximize the development instead of having a very sequential process that heavily relying on the planning side. Another example is is RAD or rapid application development. So when you first look at this, you may say, oh, that's just SDLC. We just basically changed the size of the boxes. So we have planning and analysis, and then we have design or implementation and support. So what's the difference? Well, the difference is not only the box, the design box is bigger, but everything else is smaller, and that is the most important thing, because we don't really rely on each phase that much. We just want to have a very quick plan and then planning analysis, so that we know what we want to do in general, what the business requirements are, and what we want to accomplish, and then we go right into what we call the prototype cycle. So we get the people to design the prototype, and we see that whether this satisfies our needs or not. If it doesn't, then we look at the prototype. We start changing it so that the designers will go back and make the next prototype until it satisfies everything. So the planning side is very short. The analysis phase is very short, but we spend a lot of time really refining the system, the end system themselves. So once we have everything ready, then it can be easily implemented, and the maintenance part is pretty simple. So our whole focus, or the key part of the project management, is all in the prototype development. So we make sure that before something is implemented, then everything we want is already met in this prototype. So prototyping is great when we don't really have a good idea of exactly what we want. So going back to the example of building an app, we know we want an app. We know we want to use that for customer communications, but how exactly are we going to be able to do that? So what are the responses? So are there anything that so how would the app look like and everything? So those are things that we don't really know exactly. So we may want to see a prototype being built so that we can make changes when we see something. Then we know what to change and what to modify and so on. So you can also imagine that the prototype has to be a little smaller, have to be in small scale. So if it's a really large system, then building a prototype is probably not the best idea. But on the other hand, if we know that the users don't have a good definition of good understanding, and also if the users should be involved in the whole design process, then building a prototype is much easier than having everything planned out in the beginning, because this way the user contribution or user involvement can be integrated can be integrated into the whole design process. Well, as you can imagine, there are pros and cons of each. Right? So, what a traditional versus agile, and of course, the strength of traditional is usually the weakness of an agile approach. And this chart has a very it's pretty straightforward comparisons between these two. I'd also like to point out the last one. So this is something that a lot of people don't pay much attention to, is the documentation. So going through a whole process of systems development, sometimes you just want to get the systems up and running. You just want to make sure that you can actually get the application, and then make sure that the operation is the operation requirements are met. But sometimes documentation can be very important, because you may want to go back and make some changes. You may want to add something. You may want to understand how things are done, and so on. A traditional approach like SDLC gives a very good documentation throughout the whole process. Agile approach, usually you don't see that. Whether it's with prototyping, whether it's with sprint, then the documentation can be a little iterative, a little sparse. So that's something that usually people don't pay much attention to. But at the end, if you want a lot of documentation, then maybe the traditional approach is better. So whether you want to take a traditional approach, a more sequential approach, versus a more agile, more iterative approach, it really depends on what you need. It should not be determined by the company's capability. Some companies said that, oh, we are a Scrum company, or we are a prototyping company, and that is just the wrong way of approaching this problem. The project itself will dictate what type of approach should be. So if the results are critical, if it's easy to define the results, and not a whole lot of users are involved in this whole process, then SDLC in general, the waterfall methodology will be a better one. But if there's a lot of unknowns, if the project itself are very hard to define, and also if the projects are a little smaller, if the systems requirements are a little smaller, then we can probably take an agile approach is probably a better approach. Again, it's more important. It's very important to understand, to select the right approach based on the requirement of this project or the system, instead of setting up the capabilities and apply the same capabilities to every single project. After a system is built, then we have to implement it. So this is when we call it conversion. So the reason we call it conversion is because we convert from old system to new system when we build out the new system, right? Well, sometimes I heard the reaction say, well, we don't have an old system. Let's say that we don't. Let's say that we're building up a new accounting system. We keep using the same example. Building up a new accounting system. We never had an old accounting system, so we just implement a new system and that's it. Well, when we say old system versus new system, it doesn't mean that old information system versus new information system. There are very few times that we're actually looking at a completely new operation, a completely new procedure, a completely new way of doing things. I've been doing accounting forever. We need to produce accounting reports. We need to be able to file taxes, and we so have to record everything we have to perform accounting. But before we actually have an accounting system, we actually have our own manual system. We use pen and paper. Maybe we use Excel just to record everything. So that is the old system. So it doesn't mean that we have to have an information system going from the old one to the new one. It just means that this particular operation, this particular process, we have an old way of doing things versus a new way of doing things. So there's several different approaches to convert from old system to new system. So the first one is parallel. So parallel means that we run the old system, a new system, at the same time for a while, and then we make sure that the new system works. Then we turn off the old system. So you can imagine that this is probably the most conservative approach. But on the other hand, the most aggressive approach is the cold turkey, or usually what people call a plunge or big bang approach. So basically, on one day we stop using the old system, and then we just turn on a new system and go. Okay, so this is very aggressive. This is very quick. This is usually much cheaper. But at the same time, it's very risky. What happens if the new system doesn't work? What happens if some of the requirements are not met? So what happens if the new system actually not only doesn't work, but it breaks other parts of the operations? So there are a lot of considerations on whether you pick parallel versus the the big bang. But of course, there's something in between. There's a whole spectrum of things in between these two ends. So you can take a phased approach in which you break up the new system into modules and you implement one module at a time, or you can take a pilot approach in which you implement the new system in one functional units at a time. So you make sure that it actually works within a small group of people, and then you implement to that, and then you apply to the next group and the next group. Of course, you can combine them, so you can actually take a small group and then also only apply phase 1, and then apply phase 2, and then you apply the same phase 1 and phase 2 to a second group. So the combination of phased and a pilot approach. So there's a whole bunch of different ways to convert or to implement the new system. And you really have to think through what you want to accomplish in order to pick the right approach. So some of the considerations for selecting the conversion methodology are things like the nature of the project. So what is very large, very complex. Of course, larger project or more complex project will probably require a more conservative approach. And also the organizational capability and the cost itself, right? So the faster approach usually, or the more aggressive approach usually costs less and usually is faster and it requires less resources. So and vice versa. But on the flip side of that is the risk. So if the project itself has a lot of risk in terms of not working, so when it's not working, so if it's a large project, it may break you may break the process, or you may break other parts of the operation. Then you may want to take a much more conservative approach. So you have to take all these things into consideration and decide on what you like. And one of the things that I've noticed throughout my career, it's quite interesting, is that companies usually take the opposite approach to conversion. So when you implement a small project, let's say that you're running a new antivirus program. That's actually pretty common. Many companies actually running two at the same time, the old one and the new one at the same time. But when it comes to a large project, very complex, very difficult to implement projects such as ERP and CRM, then many companies actually just turn off everything that they've been using, and then one day they just turn on the ERP and just basically port all of the operations onto the ERP system, and that of course creates a lot of risk. In terms of breaking the operations, breaking the business. Sometimes you can't even recognize any inventory. Sometimes you can't even access any customers and so on. And people do that. People take the opposite approach because they just want to avoid the potential problems, and or they're probably in denial of the risks. Because they probably understand that larger projects or more complex projects have more risks, but they're just hoping that the risk will never come up because they understand the resources in terms of time, in terms of cost, in terms of the labor are probably much higher when you cut over to a new project when the project is large and complex. So they're just hoping that everything will work on day one, so they don't have to worry about that. Unfortunately, in reality, hope is not real. So you always have to worry about the risk. You always have to worry about what has to be done. So please think through all these considerations when you pick the right conversion methodology.